Hello dear students, I am Surendra Sir, Master Teacher of Mathematics in Vedantu. In this session, I am discussing high weightage test 17 most incorrect questions done by the students. This is based on definite integration. Let's see what are those questions. So, this question says integration e power minus 1 to e square mod ln x upon x dx. I'll tell you two methods of doing this question. My first method is, method 1 is that you take ln x as t. If you take ln x as t, this will become, I think e power minus 1 limit will change to minus 1, e power 2 limit will change to 2, and this will be mod t, and dx upon x will be equal to t, will be equal to dt, because derivative of ln x is nothing but 1 upon x. So we got this into dt only. So we have to do the integration of mod t dt, that's it. Now after that, again you can have two methods. One can be that you make two cases, that from minus 1 to 0 and then 0 to 2. 0 to 2 mod t will be opened with plus sign, so mod t will be equal to t, and for minus 1 to 0 t is negative, so mod t will be opening with minus t, so minus t dt plus this thing. Now this integration will be minus t square upon 2 from minus 1 to 0, and that will be t square upon 2 limit from 0 to 2. What are we getting for this? First, if you put 0, it will give you 0, and then minus minus plus 1 upon 2, whereas this will give you just 2. So answer is 5 by 2 or 2.5. So B should be the answer of this question. So that was one method of this question. Now I would like to tell you one more method of this question. Please see. At this place itself, once you know it is minus 1 to 2 mod t dt, and we know how graph of mod t looks like. It is a V shape at 0, okay, and our integration is from minus 1 until 2, okay, and we know the meaning of definite integration by area. So the required, this value of definite integration will be given by this area plus this area. Now these two are right angle triangles. The base here is 1, height is also 1 because the slope is just 1 or minus 1. Here base is 2, height is 2. So this portion will give you area 1 by 2, half base into height, and this portion will give you area 2, half base into height. So adding these two will give you same 5 by 2. In fact, if you check, your calculation is also suggesting same thing. 1 by 2 for minus 1 to 0 and 2 for 0 to 2. So this is how this question is done. I'll tell you one more method. Please see, answer is B, and that method is that if you do not do substitution initially and you think of that I'll be breaking it in two parts. Okay, so it will be broken at e power minus 1 to 1, and ln x will be actually negative when your x is less than 1 and greater than 0. Okay, and it will be positive when x is greater than 1, and it can go till infinity. Okay, so if we keep that thing in our mind, so e power minus 1, which is less than 1 to 1, this ln x will be opened with minus sign, mod ln x will be opened with minus sign because it is negative, upon x dx, plus then 1 to e square, and it will be ln x because now it is positive upon x dx. Now also you have to do the substitution. Okay, ln x will be taken as t, ln x will be taken as t, so minus dt, minus t dt it will become. I will be taking ln x as t, so ln x derivative is 1 upon x dx is equal to dt, and when you put the limits, it will be minus 1 0, and here you will be putting ln x as u, so it will be, I think, du into u. Ln x is equal to u, 1 upon x dx is equal to du. I think you could have taken u t here also, because we are doing same substitution. This will be 0 here and this will be 2 here, and after that I think it's the same calculation which I told you in method 1. So I'm leaving this question at this place, but I think the first one where substitution of ln x is done is the fastest method. Now in this question we are given minus 1 to 1 mod x plus greatest integer x dx. Again here I can give you multiple methods. Let's start with one method first. The first method is that if I split these two, okay, so minus 1 to 1 mod x dx plus minus 1 to 1 greatest integer x dx. Okay, now you can do this integration by graph also, because we know mod x graph is v shape and it will be actually equal to 2 times 0 to 1 mod x dx, because it is even function. You can take 2 common and then only this portion area will be sufficient. Whereas this I'll be breaking in two parts, minus 1 to 0 and 0 to 1 greatest integer x dx. Greatest integer x dx. For this part, mod x will be written as just x because x is positive. So finally the integration I can write it directly, x square by 2. Mod I have removed because it is positive, and then integration is x square by 2 and it is from 0 to 1. In this case minus 1 to 0, the value of greatest integer will be minus 1 dx, and for 0 to 1 it is 0 dx. Okay, so what are we getting here? From this first part we are getting just x square and putting value as 1, so it will be 1 minus 0 and then plus integration of minus 1 is actually minus x, and we will be putting minus 1 to 0. The last part is already 0 only, so we get 1 plus, you put 0 here, so you will be getting 0 and then minus. Now please take care of all the minus signs, minus of lower limit, and there is one minus sign already in the expression, and then you are putting x as minus 1, so minus minus plus. So finally we will be getting 0 as the answer of this question. Okay, so that is one method. I can tell you one more method in which just make the graph of mod x and greatest integer. I think we know these graphs these are very basic graphs, we know them already. So mod x graph will be like this, okay, and greatest integer from minus 1 to 0 will be this thing, and then 0 to 1 it will be like this. So you can see the graph suggests the area from minus 1 to 1 will be half here, whereas area of this part, that is greatest integer, from minus 1 to 0 will be minus 1 because it is lying below x-axis, whereas it is just along x-axis, so area here is 0. So overall the area, if you check, it is 1 coming from this and it is coming minus 1 from here. So total answer is 0. So this is how also you can do it. One more method I am having for this question, please listen carefully. That method is actually for greatest integer. Mod, I think you already know. In greatest integer there is one very important property, please remember it. Yeah, greatest integer, there is one very important property is that greatest integer of minus x is equal to minus of greatest integer x or minus of greatest integer minus 1. This is when x belongs to integer and this is when x doesn't belongs to integer. Now for first part, minus 1 to 1 mod x dx, I will not do it. This we already know, we have done it in two ways already, answer is 1. Now let's talk about this integration, minus 1 to 1 greatest integer x dx, and let me call this as I2. Okay, now if I use King's rule, because minus 1 plus 1 is 0, so I2 will be equal to minus 1 to 1 and this will become minus x inside greatest integer x dx. Now dear students, for minus 1 to 1, this greatest integer minus x, inside this minus x will take only 3 integral values, that is minus 1, then 0 and then 1. But they are just small points, single points you can say, they will not cover any significant area, you can ignore them. You can take this greatest integer minus x and this minus x always as not integer. If I take this as always not integer, it will become minus 1 to 1 minus greatest integer minus 1 dx. Now you can see if you split it in two parts, so minus 1 to 1, minus sign outside, greatest integer x dx, and minus 1 to 1 1 dx. This is nothing but your I2 only. So this I2 is actually equal to, let me write it here or here only, I2 is equal to minus I2, okay, and minus the integration of 1 will be x, and if you put the limits, I think it will give you 2 here. So I2 minus I2 equal to minus I2, if you take this I2 here, I think we are getting this 2 equal to minus 2, so I2 is coming out to be minus 2. You may be thinking that it is so lengthy, why we are using this method 3 here. Let me tell you, this method will be useful if you are given this, let's say minus 10 to 10. Suppose this greatest integer of x was asked from minus 10 to 10. In that case, you have to split in multiple steps, or minus, like minus 1 to minus 10 to minus 9, and then minus 9 to minus 8, and so on. But if you know this property, this will be useful there also. In fact, you can use this property in those questions also where we are given, let's say 0 to 2 pi and greatest integer of sine x, or sine x multiplied by 4. Now, dear students, you must have done these kind of questions where you split sin x in multiple parts where it is taking integer values. But for sin x, if it is given, it will be taking values between minus 4 to 4. So you have to split at 8 places or 9 places maybe. So you have to be very careful. But if you use that property, King's rule, it will become minus 4 sin x in very first step. And then use this property I told you. You can assume all values being only non-integer, because it will take integral value only at some finite points whose area is just ignorable. You can ignore that. So this will give you answer very fast as compared to if you split it in multiple parts. So please be careful and please note it down that this property is useful whenever you, after using your King's rule, you are able to write I in terms of minus I plus something. This is one very important. Okay. Coming to this question, we are given fx be a differentiable function such that fx plus f of 2 minus x is equal to 0 for all x belongs to R, and I1 is 0 to 1 x square f dash x dx, and I2 is 0 to 1 x fx dx. Then we have to find I1 upon I2. Okay. So what we will do, because they have given this f dash x here, so they are actually prompting us, they are actually invoking, they are saying us that you take this as second function, take this as first function, that is integration by parts. So if you do this integration by parts, the first function as it is, second function integration will be fx because it was f dash, and this will be 0 to 1 minus differentiation of first function integration of second function dx. 0 to 1. Now please listen carefully. Here, if I put x is equal to 1 in this relation, I think you can see this gives you 2 times f1 is equal to 0. So f1 will be 0. So if I put x is equal to 1 here, this will give you 0. If you put x is equal to 0, this x square will make it 0. So in both cases, we are getting this to be 0. And then minus, if I take 2 common, I think I have made a mistake here. It was 2, not x square. Okay, so it will be actually 2 times I2. If I take 2 common, then it is just x into fx dx from 0 to 1. So I1 is equal to 2 times I2 with minus sign. So I1 upon I2 will be equal to minus I1 divided by I2. I think on the right hand side it is just minus 2. So answer of this question is A. Dear student, for such questions, I think this is the method. There are so many questions of this type where I1 is given, I2 is given, and after doing certain integration by parts or maybe some reduction method, you get I1 in terms of I2, and then you find their ratio, or maybe some other things also can come up. So this is one very standard variety of question, very important. You can expect this kind of question in your JEE mains also. The value of integral 0 to pi x sin x upon 1 plus cos square x dx. Now, this question again is based on King's rule. What is King's rule? Where we add two limits 0 and pi. So 0 plus pi is pi, and we write x as pi minus x, and sine also pi minus x, and cos also pi minus x. So everywhere, wherever x is written, we will be replacing that x by pi minus x. But sin pi minus x is sin x, and cos pi minus x is minus cos x, but because it is with square, so that minus sign will not be written. It is same as cos square x only. Now the given I and this modified I, if you add, that means I plus I 2i, this plus this, you can see x upon this sin x upon 1 plus cos square x can be taken common, and here you are having x and here we are having pi minus x. So x will be cancelled and we will be getting pi here, and this is from 0 to pi. Okay, pi can be taken common outside, and then if you use this property King's rule, you can see this function is not changing at all. So 0 to pi can also be written 0 to pi by 2, taken 2 common, and this pi also outside, and this is actually equal to 2i. So sin x upon 1 plus cos square x d. 2 we can cancel. Now we will be putting cos x as t. We will be putting cos x as t. So what we will be getting? We will be getting So we will be getting this I equal to pi into 0 to 1 minute. Actually limit I will not put. First I will be putting, because cos x is t, so minus sin x dx will become equal to dt. So this sin x dx will become equal to minus dt, and here it will be just 1 plus t square. But if you look at the limits, because we are putting cos x as t, so at x is equal to 0, t will be 1. At x is equal to pi by 2, t will be 0. So this integration will be from 1 to 0. You may like to write this as 0 to 1 also, dt upon 1 plus t square. And then I think integration is very simple. Tan inverse t, putting limit from 0 to 1 will give you pi into pi by 4. So we get this as pi square by 4. So answer of this question should be pi square by 4. A is the answer of this question. I think same method. I don't think there can be any other method for that. More or less it will be same, that first you have to eliminate x by using King's rule, then adding them, and then after that step you may write cos x as t, or someone may say that sir, I will like to write cos x as sin x and sin x as cos x after applying King's rule, but there is no much advantage. It's same thing as this thing. Now coming to this question where we are given integration 1 by 4 to 3 by 4 cos of 2 cot inverse under root 1 minus x upon 1 plus x dx. Now dear students, whenever we are given this kind of expression, and you must have done in your inverse trigonometry, then differentiation, and then integration. There is one very common, very standard substitution, and that is x equal to cos 2 theta. If you put x is equal to cos 2 theta, we will be getting 1 minus x upon 1 plus x is equal to 1 minus cos 2 theta upon 1 plus cos 2 theta. 1 minus cos 2 theta is 2 sin square theta, and this is 2 cos square theta. This will become tan square theta. Okay. Now dear students, one very important thing, whenever we are putting x is equal to cos 2 theta, the angle 2 theta has to be taken in principal domain of cos, because x is from 1 by 4 to 3 by 4, so it is all positive values, so 2 theta will also be in first quadrant. Will be in first quadrant, and if 2 theta is in first quadrant, then theta is even having smaller range, but all the range are in first quadrant only, and that is more important for me. Why it is important, I'll tell you. So if theta is in first quadrant, so tan theta will be positive, and because this thing if written inside under root, we will need to apply mod. Under root of tan square theta will give you mod tan theta, so this will become is cot inverse cot inverse of under root of 1 minus x upon 1 plus x will be equal to cot inverse tan theta, and I can write this as pi by 2 minus theta. I can write it as pi by 2 minus theta. So the integration that is asked, that is cos of this thing, will be 2 into pi by 2 minus theta, and this will be cos of pi minus 2 theta. This is equal to minus cos 2 theta. Okay, now dear students, we actually put cos 2 theta as x. So this cos minus cos 2 theta will be equal to minus x only. So the integration is actually equal to 1 by 4 to 3 by 4 minus x dx. So the integration is minus x square by 2, limit from 1 by 4 to 3 by 4. If we put 3 by 4, we will be getting minus 9 by 32, and minus plus 1 upon 32. So it becomes minus 1 upon 4. So that's the answer. Dear student, there is two things that I like to tell you. The one thing is that in this substitution that we did, we have not done this substitution for integration. I mean to say, I have not taken dx in terms of d theta, which you could have done, because dx will be equal to minus 2 sine 2 theta d theta, that you can replace it here and then you can do the integration and you will get the same answer. But actually, after putting x as cos 2 theta, this integrand is actually coming out to be cos 2 theta only. It is coming out to minus 2 cos theta only. So why not we take this minus cos 2 theta as x only, so that my integration will be very simple. There is no need to write the derivative of cos 2 theta as minus 2 sine 2 theta d theta, because their calculation will be slightly more, not very much but slightly more. You can check that with that method also it will be same. Now the second thing, if you look at this expression, this 1 minus x upon 1 plus x, if x is 1 by 4 to 3 by 4, it will be less than 1. Now cot inverse being decreasing function, this thing will be greater than pi by 4, because cot inverse 1 is pi by 4, cot inverse being decreasing function, it will be greater than pi by 4. Multiplying this by 2 will give you actually this entire thing greater than pi by 2. Now greater than pi by 2 means cos of this thing will be negative. So if it is negative, you can see this function is actually negative. It is negative. Actually we checked it, it was coming out to minus x. So it will be something like this. Minus x means going down, yeah, like this. So at 1 by 4 it will be minus 1 by 4, at 3 by 4 it will be minus 3 by 4. So this is the area that we are looking for. Okay, coming to this question, where we are given, we are asked the value of integral 0 to pi by 2 dx upon 2 plus cos x. I think this is again one very standard variety of questions, I will say, where we have to write cos x as, 1 minus tan square x by 2 upon 1 plus tan square x by 2. After putting this thing, after writing cos x like this, it will be 0 to pi by 2, and in the denominator it will be 1 plus tan square x after taking LCM into 2 here, plus 1 minus tan square x by 2, and this 1 plus tan square x by 2, which is secant square x by 2, will come in the denominator, come in the numerator actually. Okay, now we can take tan x by 2 as t, we can take tan x by 2 as t. So in the denominator it will be 2 minus 1, so t square, and 2 plus 1 3. Okay, and secant square x by 2 dx will be 2 dt. Actually I have taken tan x by 2 as t, so secant square x by 2 into 1 by 2 into dx will be equal to dt. So this 2 will come from here, and also when x is 0, this lower limit will be 0. When x is pi by 2, this upper limit tan pi by 4 will be 1 here. So this is what we have to integrate. So one very simple question after this, it becomes 2 upon root 3 tan inverse of t upon root 3, and limit of t is from 0 to 1. Dear students, I have used this formula 1 upon a square plus x square dx, which is equal to 1 upon a tan inverse x upon a plus c. Okay, please remember all these standard formulas without which you cannot do integration. Putting 1 will give you 2 upon root 3 into tan inverse 1 upon root 3, which is pi by 6. For 0 it will be 0. So answer will be pi upon, I think, 3 root 3 of this question. Pi upon 3 root 3, that is a. So answer of this question is a. Now coming to this question, we are given integral mod sin x dx from 0 to tan pi. Okay, dear students, tan, sin x, cos x, all functions are periodic function, and their periods are at least 2 pi. Some are having pi also, means lesser than 2 pi. You can say at most 2 pi, lesser value is also possible. When you apply mod on sin or cos, their period which was otherwise 2 pi now becomes pi. Fundamental period is actually equal to pi. So I can write this integral I1 as taking tan common and 0 to pi mod sin x dx. Why I am saying so? Because for every interval 0 to pi or pi to 2 pi or 2 pi to 3 pi and so on, the integral has to be same. So I can take tan common because there are total 10 fundamental periods for this function where we are integrating it. So taking tan common, 0 to pi mod sin x dx. Between 0 to pi, this is actually positive. So 0 to pi, it will be just sin x dx. Sin is positive. So integration will be minus cos x. And we put limit from 0 to pi. This will be tan into, for pi it will be minus minus plus 1, and then minus for lower limit, and this minus sign for this. Putting 0 will give you 1. So answer is 20 of this question. Dear students, those who know some standard results, like we know that mod sin x graph is like this: 0 to pi, then pi to 2 pi, then 2 pi to 3 pi, and so on. Now for every interval, this is one very standard thing, that integration from 0 to pi by 2 is 1 of sin x or cos x. So if this is 1, this will also be 1 by symmetry. So 0 to pi, the integration is 2, and we are talking about 10 periods, 10 fundamental periods. So the answer will be B, 20. So that's it for this session. Thank you so much. Bye, bachcho. Take care.